Hello everyone, it's Dr. C. What I'd like to do in this video is look at how we prepare a solution of a given molarity and then how we would actually do the calculation. So we would know how much solid, say, to weigh out to make a given solution. So let's look at the process first. So here's a sequence of photos that illustrate the process. And actually the first step is kind of skipped. You will notice that there's a solid at the bottom of this flask. So the first thing we would have to do is weigh out the appropriate amount of solid in this case. Okay? And we'll look at the calculation in just a minute. We would then clearly have to know what volume of solution we'd want to make. So we would choose the appropriate size volumetric flask. All right? For example, if we want to make 500 milliliters of solution, clearly we're going to choose a 500 milliliter volumetric flask. Then we would add our solid, in this case, to the flask. This next step then shows that we are making an aqueous solution. Our solvent is water. Right? So we're looking at a two-component solution, probably some ionic solid and water. So now we add the water. All right? Before you fill to the mark on the flask, and we'll talk about the mark in just a second, we're going to swirl that solution to start the dissolution process, start dissolving that solid in the water. Stir to dissolve, swirl to dissolve. All right? Don't fill it all the way to the mark. It's going to be hard to see in this photo, but volumetric flasks have an etched line in the glass to mark the volume mark. So say 500 mils in this case. We are then going to carefully use a dropper to fill with water to the mark on the flask. All right, and of course, if we're doing an aqueous solution, we would have a U-shaped meniscus, and we would like to have that bottom of the meniscus resting on that mark. All right, last step. Put the stopper on. Note the stopper there. Don't forget that. Put the stopper on the flask, and then we're going to invert that flask a number of times to thoroughly mix. We want to make sure that we have a uniform concentration throughout that solution. All right, there's the process. That's how we make a solution of given molarity. But we need to know how much of this solid we need to weigh out to make that solution. So let's do a calculation. So we're in the laboratory. We want to make 250 milliliters of a 0.1 molar copper sulfate solution. Determine the mass in grams of copper 2 sulfate that we need to prepare the solution, and then quickly describe how you would do this. We've kind of gone through the process, but it'll be nice to kind of review at the end. All right, so let's look at the definition of molarity to start. Molarity, capital M, is moles of solute. Our solute in this case is the ionic solid copper sulfate per liters of solution. All right, and remember the solution is the solute and solvent together. Solute and solvent together. All right, so let's look at what we have. We know what molarity we want to prepare. That's given. We know what volume of solution we want to prepare. That's given. Now, it's given in milliliters, but do we know how to convert to liters? Yeah, sure we do. And so look at what we can calculate. We can calculate moles of solute. Is that what we want? Pretty close, actually, right? We want grams. Do we know how to convert from moles to grams? Yes, absolutely. We need the molar mass of copper 2 sulfate to convert from moles to grams. Okay, so there's the process. Let me show you something else very quickly. If we take the molarity equation and we multiply both sides by liters, we end up with mole solute is equal to molarity times liters. Okay, so it's probably a good idea to know that because you'll probably have to do that quite a bit. If we want moles, we can take molarity times liters to get moles. All right, so our molarity, 0.1, and let's write it as moles per liter. And then we're going to multiply that by liters. Now, so we need to convert that 250 milliliters to liters. But let me show you a quick way to do that. Milli just means 10 to the negative third. So instead of writing m for milli, let's just write the number that it represents. There's our conversion to liters. And you can punch that number into your calculator as I have it written on the screen. Punch in 250, hit your key to do scientific notation, and then put in the negative 3 exponent. Okay? On a TI calculator, that would be the EE key that you would want to use. And you'll notice that liters cancel, leaving you moles. Kind of nice. Okay, so let's see what we get here. In terms of moles, we are going to get 0.025 moles of solute, copper 2 sulfate. All right, so we're almost done. We now need to go from moles to grams. We know how to do that, right? We need the molar mass of copper 2 sulfate. Mass of copper is about 63.55. Sulfur is about 32.07 grams per mole. Each oxygen is 16 grams per mole. You should end up with a molar mass about 159.62 grams of copper sulfate is equal to 1 mole of copper sulfate. Okay, moles cancel, and we end up with 3.99 grams of copper sulfate. And there's our answer. So what do we need to go to weigh out on our balance? We need to go weigh out 3.99 grams. Now, let's quickly then describe how we would make this solution. Okay, so let's scroll back up. We would weigh out that 3.99 grams. We would then carefully add that amount to our flask. Okay, you might want to use a funnel to do that. You would then rinse the funnel with water to wash any remaining solid on the funnel into your flask. We would then fill partway, the second picture, fill partway with water, swirl the flask, this next step, to start the dissolution process, start dissolving that solid. We would then get an eyedropper, carefully fill to the mark to make sure we had the right solution volume. In this case, how much solution were we making? 250 milliliters. I guess I forgot to mention at the beginning, we better choose a 250 milliliter volumetric flask, right? That would be a good idea. And then we're going to put the stopper on, don't forget the stopper, and we are going to invert that flask a number of times to thoroughly mix the solution. So there you go. There's how you would do the calculation using molarity, and then the process of actually making that solution in the laboratory. All right, I hope this video helps. Have a wonderful day. Take care.